Lesson 3 in the factoring of quadratics. This time we're going to work on factoring quadratics with a leading coefficient other than 1. So your learning target is as simple as I can factor a quadratic trinomial in the form of ax squared plus bx when a does not equal 1. Last lesson, a equaled 1, but this one, a does not equal 1. A couple things to remember when factoring trinomials. You're going to factor out the greatest common factor. And so we practiced that a couple lessons ago. We'll continue to practice it in lessons to come, but you can always factor out the greatest common factor if possible. Then you're going to factor out the rest of the trinomial with the strategy you prefer. I'm going to teach you two strategies. One is known as factoring by grouping. The other one is that box method or the area model. So it's kind of up to you. And then the results will be the product of two binomials. And you will rewrite the GFC first, if needed, if that happened, and then followed by the product of the two binomials. Look at this first example here, and I'm going to use the area model, the box model first, just to kind of show you. Some of you may have used this model. Some of you are like, I don't like it. That's kind of up to you. So first of all, I'm going to notice there's no greatest common factor I can take out. 6, 11, and 4, the greatest common factor is 1, technically, mathematically, it's not going to do anything, and there isn't a variable. So I can skip that first step. It's not going to help me with the greatest common factor. Remember that the a comes up here. Change color so it's easier to see. So the 6x squared is here, the 4 is here, and remember you're going to take this box plus this box, and they have to add up to 11x. Now, what's different about this one is notice that I not only just have x times x anymore, I have to get the value of 6. And so I have to think of my factors of 6, 1 and 6, 2 and 3. Down here, I have 4. So 4 times 1 and 2 times 2. So it's a little bit more work and a little bit more logical thinking to think about what combination is going to work to get me 11x. So I'm just going to throw some numbers out here. You kind of use your logic. I'm just going to start with 3 and 2. No reason. I just kind of like just not start with the 6 and 1, but that's just my opinion. 2 and 2 here. So remember to find this area of this box. You're going to take 2 times 3x, which is 6x, and 2x times 2 is 4x, and I can already tell when I add those together, it's only going to get me 10. So I know those two won't work. Now, I would only change one at a time or you're going to get confused. So I would change the 4 to 4 and 1 this time to practice. If I put a 4 here, logically, I'm going to know that that's not going to work right away because if I have, let's get rid of these. If I have a 4 here and I take 4 times 3, that's 12, and 12 is already bigger than 11, so I can't add anything to get 11. So I know 4 is not going to go there. If I try 4 down here, so I have 3x times 1 is 3x, 2x times 4 is 8x, and 8x plus 3x does equal the 11x. So there is my trinomial factor down to 2 binomials, the product of 2 binomials. Remember when you write these, it doesn't matter which one you take first. Here are your 2 binomials. So it's going to be 2x plus 1 and 3x plus 4. Okay, so the box method. A little bit of guess and check, but I would totally say it's logical. It's not like you're guess and checking every number, you're just going to check the factors that are there. It just takes a little bit more work because this isn't just x squared. It has a coefficient other than 1 there. Your other option is the grouping. I actually prefer this one because I like to get right down to it and get the right answer, but that's kind of up to you. So here is the grouping. So you're going to think about kind of like we did in the last lesson. You're going to think of products, but this time it's the product of A and C multiplied together. So in this case, that's 6 times 4, and 6 times 4 is 24. And then you're going to think of a sum of B. In this case, same thing we did last time, it has to be 11. So you have to think of factors that multiply to get 24, but when you add them, it's going to give you 11. Well, 3 times 8 is 24. 3 plus 8 is 11. And that might kind of sound familiar because we just used those in our box method. So they do have the same idea. So 3 and 8, or what we're going to use. I'm going to erase it just so I have a little bit more room to write. Okay, so how you write this is you're going to take your a, so 6x squared. You're going to break up that 11x with the 3 and the 8, and it doesn't matter which one you put first. Mathematically, it's going to give you the same answer no matter what you do. Again, this is called factoring by grouping. Okay, so you're going to factor by grouping the first two binomials and then the second two binomials. And then you're going to use that idea of greatest common factor. So the greatest common factor in this first grouping would be, well, factor of 6 is 3, and of course 3 is 3. So I have a 3, and then notice they both share an x, so I'm going to pull that x out here, and then I'm going to divide. So it's just like your last lesson. So 6x squared divided by 3x would leave me with 2x. And then 3x divided by 3x leaves me with 1. Over here, you do the same thing. Look at it. Greatest common factor is a 4. So I'm going to pull the 4 out. They both don't have an x, so then it'd be x. Oops. Work that backwards. 8x divided by 4 would leave me with 2 x's. And then 4 divided by 4 leaves me with 1. Now, the thing with factoring with grouping, these two have to be the same binomial because that is one of your sets of binomials. Okay, and if you recognize that from the last method, you should. And then the second binomial comes from what's outside with the greatest common factors. So in this case, it would be 3x plus 4. So those would be another way to factor if you don't like the box method. A little more precise, you get the correct answer. The other one is more kinesthetic, logical thinking, just whatever you prefer to answer these. Here's another one. This time I'll do, we'll do the grouping first because I went the other way. So we're going to go you're going to do the product of A and B, or sorry, A and C. So that's 2 and negative 21, which is negative 42. And the sum of B, in this case, is 1. So let's think. I need to get negative. So negative 42, 1, there's no way that's going to be 1. 2 and 21, probably not happening. It's a sum of 1, so I'm going to look for two numbers that are kind of close together. Oh, 6 and 7. Now, one of them has to be negative because I need negative 42. So if I want, but sum wants to be positive, that means my my 6 has to be negative. So negative 6 times 7 is 42, which was my goal. And then negative 6 plus 7 does equal 1, so I know that's my two factors. Now I'll leave those there this time so you can see it. So again, you're going to take the x, so 2x squared plus, and it doesn't really matter which way you do this. Just take one of your factors, so we'll put negative 6 here. We're going to group those together, and then we're going to group together the second one, so that'd be 7x minus 21. Okay. So then you're going to look for the greatest common factor out of each one. So I have a 2 and a negative 6, so my common factor is 2. And then that's going to leave me with, oops, I forgot my x on that one. That's why I'm so confused. 6x, because these have to make 1x. So I had to have factor out the 2 and the x, which would leave me with x, because 2x squared divided by 2x is x, and then negative 6x divided by negative positive 2x is going to leave me with a negative 3. Over here, common factor is 7, so I'm going to factor a 7 out. It's positive there. So 7x divided by 7 leaves me with x. Negative 21 divided by 7 leaves me with negative 3, which again is a good sign because these two need to be the same. So one of my factors is x minus 3. And my other factor is the 2x and the positive 7. So those are the two binomials. Now remember, you can check those. It's a little easier visually to see, but you can multiply this binomial by this binomial, and I can promise you, you will get our original trinomial. Okay, last example. I'll start with the box on this one for my box fans. So this is 10x squared. This is 3. We want to figure out what plus what is going to equal 17x's. Well, 3 is nice because 3 is prime, and because 3 is prime, that means it can't be anything other than 1 and 3. So this one is kind of nice because one of them is already prime. 10 can be 10 and 1, or 5 or 2. So you really don't have a lot of choice on here. Let's start with 2x here and 5x here. Because 2x plus times 5x is 10x squared. See if this works. So 2x times 3 is 6x's. 5x times 1 is 5x. We add these together, only equals 11. So that's not right. Oops. Okay, whoops, that's going to be 1. Okay, let's try this one here. I'll put 1 back here. I tried 5 there, so let's go 5x here and 2x. Again, I went flip to the other factor. I would just flip-flop where they're at because they're being multiplied by something else. So 5x times 3x, or 3, is 15x's, and 2x times 1 is 2x, and 2x plus 15 is 17x. So we found it already. So these are my two binomials. So you have 2x plus 3, and then we have 5x plus 1. So again, this is the area model formula. This one is the grouping model to factor, or factoring by grouping. Okay, and then on example 1, I showed both. So you get to decide. I gave you an example of how to do them, the box method twice, and then the factoring method twice. Again, if you need help, please don't hesitate to email me. I can jump on a Google Meet anytime to help you. Factoring is something that you will do in Algebra 2, so it is something that I need you to have a basic understanding of before you get into those more complicated factoring problems in Algebra 2.